everybody, welcome to the Session 8 Classwork solution video. The topic is exponents and logarithms. If you haven't already tried the classwork, go ahead and give that a shot, and then come back here to check your answers. Let's get started.
First, we know that the square root of 3 is 3 to the 1/2 power. So 3 to the 1/2 power times 3 to the 1/2 power is 3 to the first power because a half plus a half is 1. So this is just 3. 12 divided by 3 times 2, we just solved that with order of operations and we get 8. And 4 to the 3/2 power means that we have the square root of 4 cubed. Now, we know that the square root of 4 is going to be 2, and so we have 2 cubed. 2 to the 3rd power is just 8. And so the value of 4 to the 3/2 power is 8. So then we have 3 plus 8 minus 8, and so the answer is 3. So we're going to distribute this exponent into these parentheses. So 2 to the 6th power is just 2 to the 6th. And then we have to multiply the two powers on y. So it becomes y to the negative 24. Now, 1/2 is just 2 to the negative 1st power. So when we multiply this in, we do 2 to the negative 3 because we have to multiply it by the outside exponent and y to the 15. So we get that it is 2 to the 3 times y to the negative 9 because we added the exponent since we're multiplying them together. 2 to the 3 is 8 and y to the negative 9 is just the coefficient divided by y to the 9. First, we're going to figure out how much 110.4 billion is. So we actually just multiply by 10 to the 9 because a billion is 10 to the 9. And then we do 270.3 times 10 to the 6th because a million is 10 to the 6th. Now, when we divide these two, we're going to get the ratio of the actual numbers times 10 to the 3, which is going to be 408 text messages per person.
What we're going to start by doing is dividing 2.4 by 8, which is 0.3. Now, 0.3 is equivalent to 3 times 10 to the negative 1. What we did is we just put this into scientific notation. Now, we have 3 times 10 to the negative 1 times the 10 to the 5 because we had 2.4 times 10 to the 5 initially. Now, remember, when we multiply two exponential expressions with the same base together, we add the exponents, and this becomes 3 times 10 to the 4. Now, because we have 3 times 10 to the 4, we just multiply this out, and we get 30,000. And that is the answer.
What we're going to do is we're going to look at each individual variable. So we have on the numerator x to the negative 2 because that's 2 times negative 1. And on the denominator, 4 times negative 3 equals negative 12. Now we're going to look at y. On the top, we have y to the 14 because that's 2 times 7. And on the bottom, we have y to the negative 3 because that's 1 times negative 3. Next, we look at z. On the top, we have z to the 8. And on the bottom, we have z to the 15. 8 is 4 times 2, and 15 is negative 5 times negative 3. Now, remember that when you divide exponents, you subtract the bottom from the top. So we get x to the 10, y to the 15, and z to the negative 7. So on the numerator, we have the two positive exponents, x to the 10 and y to the 15. And then on the bottom, we have the negative exponent, z to the 7th power. Notice that it could just be written log. We don't have to write that base 10. So now let's try to simplify the argument. So we have 10 to the 4th power times 10 to the 3/5 because it is 10 cubed to the 5th root. And then we just add those two together because when you multiply two exponents together, you simply add them. And we get 10 to the 23 over 5. Now, log base 10 of 10 to the 23 divided by 5, we can just take that exponent and make it a coefficient. So 23 divided by 5 times log base 10 of 10. Now, remember, whenever you have log base number of a number, it's just 1. So we can cross that out and get 23 over 5. We're going to look at the Loma Prieta earthquake and the 1906 earthquake, which were two earthquakes that struck San Francisco. So let's call the Loma Prieta earthquake X and the 1906 earthquake Y. X is going to equal 10 to the 7.1 power, because it's 7.1 on the Richter scale, times I. Now I is the standard earthquake, and so it is 10 to the 7.1 times this in tenths of I. So Y is 8.3 times I, because it is 8.3 on the Richter scale. Now when we divide them, we get 10 to the 1.2, which is roughly equal to 16, and that's the answer. Now we're going to look at the 1906 earthquake and the Colombia, Ecuador earthquake. So the 1906 earthquake is going to be X, and the Colombia, Ecuador earthquake is going to be Y. So X equals 10.83 times the standard earthquake I. And Y is going to be equal to 4 times that. So 4 times 10.83 times I. 10 to the 0.83 power. Now, we're going to take the log of that, log base 10, of Y divided by I. So this is because on the Richter scale, you find the Richter scale rating by dividing it by the average earthquake. Now, since it has Y in it, or it has I in it, it's just going to cancel out. So we just have log base 4 times 10 to the 8.3 power, and when you actually take that logarithm, you get 8.9. So we put 2 to the power of each side, so we get that 2 to the third power is equal to 25 minus x. 2 to the third power is equal to 8, so 8 equals 25 minus x. Now we just have to isolate x, and we get that x is going to equal 25 minus 8, and 25 minus 8 is just equal to 17. We start by subtracting 4 from both sides, so we get 3 log 2x equals 12. Divide both sides by 3 to get that log 2x equals 4. Now remember, this is log base 10, so this is equivalent to saying 10 to the 4th power is equal to 2x. 10 to the 4th power is equal to 10,000, so x is equal to 5,000. So 8 to the 10th power is going to be the same as 2 cubed to the 10th power, because 8 is just 2 cubed. Now I multiply those two exponents together, and we get 2 to the 30th power. Now we have 2 to the 30th power times 5 to the 22nd power. So we have 2 to the 8th power times 2 to the 22nd power times 5 to the 22nd power. Now 2 to the 22nd power times 5 to the 22nd power is just 10 to the 22nd power. So we have 2 to the 8th power times 10 to the 22nd power. Now remember, the problem is asking us for how many digits this has. So we need 22 zeros from 10 to the 22. And we also need however many digits are in 2 to the 8th power. So we know that 2 to the 8th power has 3 digits, because 2 to the 8th power is 256. Now we just add these digits. We have 22 zeros plus 3 digits, and that is 25 digits in total. So we're going to use the given formula, y equals a e to the kt. Now, y is equal to 10.78 million, and a is equal to 7.99 million. Now, we are looking for k, and t is 13, because that's the difference between 1990 and 2003. So we have 1.35, we just divided both sides by 7.99, and then we take the natural log of both sides. So we get 13k is equal to the natural log of 1.35. And the natural log of 1.35 is going to be roughly equal to 0.300. Now we're going to divide both sides by 13, and we're going to get that k equals 0.02. So first, we know that we can multiply the arguments of these two logarithms because they're added together. So we have log of x plus 2 times x minus 1 is equal to 1. Now this means that x plus 2 times x minus 1 has to equal 10. So we multiply this out and we get x squared plus x minus 2 equals 10. Then we subtract 10 from both sides and get x squared plus x minus 12 equals 0. We factor it and we get x plus 4 times x minus 3 equals 0. Now we know that then x needs to equal either negative 4 or positive 3. With negative 4, that makes the arguments of the logarithms both negative numbers, and we can't have negative arguments for our logarithms, so negative 4 is an invalid answer, and the answer is 3. So we're going to use the base change formula, and what that means is that if we have log base 10 of e, that's the same as log base x of e over log base x of 10. Now x can be anything, but for our purposes, we are going to make x equal to e. And so this means that log base 10 of e is equal to log base e of e divided by log base e of 10. Now, let's look at the top first. Log base e of e is just ln of e. Log base e of 10 is just ln of 10. ln of e is equal to 1. That was one of the logs to memorize. Now, that just means we have 1 divided by ln of 10. Now, what we're going to do is just distribute. So let's start with the first term. This is just going to be x, because we have x to the 1/4 times x to the 3/4. Next, we multiply it into the next term, and we get x to the 3/4 times y to the 1/4. Let's go for the next term, and we get x to the 1/2 times y to the 1/2. And then lastly, we're going to multiply x to the 1/4 times y to the 3/4, and there's no simplification there to be done, so we just have x to the 1/4, y to the 3/4. Now let's move on to the y term. So we have y to the 1/4, x to the 3/4. Well, we already have one of those terms, and this is negative. So we have minus x to the 3/4, y to the 1/4, which is going to equal 0. And then obviously we're going to have no more just x terms, so that's just going to equal x. Let's move into the next term. Again, we're just subtracting x to the 1/2, y to the 1/2. Since we have a positive and a negative one of those terms, they sum to equal 0. And then the same thing is going to happen for the next term. Again, we have a positive and a negative, x to the 1/4, y to the 3/4. And so that is going to equal 0. Next, we multiply the final term out, and that's just negative y, because remember, we do have that minus sign. And so that's just obviously going to be the only all y term. And so in total, we just have x minus y. So this is a difference of two squares on the bottom, and we know that x to the 1/2 squared is just going to be equal to x. So we know that we have x to the 1/2 squared minus y to the 1/2 squared for this difference of squares. And so that just turns into x minus y. Now, we have to notice that this x minus y term on the bottom is the same as that one on the top. So they actually cancel out. And we're just left with that one term on the top, x to the 1/2 squared. Now, obviously, we know from up here that that's just equal to x, and that's the answer. So 5 to the 3x minus 1 is going to equal log base 4 of 64. Since 4 cubed is 64, that's just equal to 3. Now, we're going to take log base 5 of both sides. So we're going to get 3x minus 1 equals log base 5 of 3. Now, you're going to have to use your calculator to evaluate this, but 3x is going to be equal to log base 5 of 3 plus 1, and that's going to be equal to 1.68, because log base 5 of 3 is about 0.68. Divide both sides by 3, and we are going to get 0.56 as the answer. So we can actually use the division rule here since we are subtracting. So it's log base 2 of x divided by x plus 3 equals negative 3. Now, we know that that means that x divided by x plus 3 equals 2 to the negative 3. And we know that 2 to the negative 3 is equal to 1/8. Now we cross multiply and we get that 8x equals x plus 3. We subtract x from both sides. We get 7x equals 3. And then we just divide by 7 to get x equals 3 over 7. So first we draw the antenna, and then we're going to draw the wire. The wire is obviously 108 meters. It says that in the question. And the angle of elevation on top of the antenna setting along the wire is 42.3. Since these are parallel lines, that is going to be 42.3 inside the triangle as well. So then we just know that sine of 42.3 is equal to opposite over hypotenuse. And so that's x divided by 108. And then we just isolate x. You use your calculator to evaluate the sine expression. And we get that x equals 72.7. Now, for this one, we are going to look at A is equal to $17,000. T is obviously equal to how long? That's what we're trying to find. R is 6%, which is 0.06. And then P, the principal invested, is $5,000. So let's plug this in. So we have 17,000 is equal to 5,000 times e to the power of 0.06 times t, which is just x because we don't know what it is. So we divide both sides by 5,000. We get that 3.4 equals e to the 0.06x. Then we take the natural log of both sides, so we get ln 3.4 is equal to 1.22, which is equal to 0.06x. Now from here we just divide by 0.06 and we get that x equals 20.4 years. Now we know that A is going to be equal to PE to the RT. Now recall that A is going to be 15,000 because that's what we want to end with. T is given, it's 17 years. We're trying to find P, and R is simply 0.06. It was given in the first part of the problem. So we just set up this equation. 15,000 equals P times E to the 0.06 times 17. Now we go 15,000 is equal to P times 2.77, which is just the evaluation of e to the 17 times 0.06. So then we just divide by 2.77 and get that P is equal to $5,409. That's it for today, everybody. I hope you enjoyed this video, and more importantly, I hope you learned something. I'll see you all next time. Don't forget to like this video, subscribe to the Agora Math Circle YouTube channel, and leave any questions in the comments.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!